Okay, so today I'm going to talk about Redox Reaction. Okay, Redox Reaction. Dun dun. Dun dun. Okay, so do you know how to cancel? It's very simple. All you have to do is dun, cancel. So what is oxidation and reduction? Okay, so oxidation is gaining of oxygen atoms or loss of hydrogen atoms, or loss of electron reduced, loss of oxygen reaction, gains of hydrogen atoms, or gains of electrons. And it's easy. All you have to do is say O2 and the way is gone. And right here, and you see something, all you have to say is O2 it's gone. Okay. And redox reaction. Now let's see redox reaction. So one substance has been oxidized and another is reduced. It can't happen alone. It can happen by itself, actually. So if there's redox reaction, there must be oxidation reaction. If there's oxidation reaction, there must be redox reaction. It always happened at the same time. Okay, next. Reducing agent and oxidizing agent. What is reducing agent? What is oxidizing agent? This is first. A reducing agent is to make others reduce, so it oxidizes by itself, and oxidizing agent is to make others oxidize and reduce the cell. Okay, and O2 is gone. Okay, next. How do you assign the oxidizing agents? So it's very simple. The first one, usually you will think is just use the chemistry way. Usually we just see, oh, C can be positive or negative, and H bond is usually positive 1, so this is negative 4. And if the element is 0 and C is now, O is usually negative 2, and this is positive 4 and positive 1, negative 2. And carbon is increasing oxidizing state, which is oxidized, and oxygen, which is reduced. But not always. So you can also have to use another way. Method is called electronegativity. So you can draw it if you can understand. You can draw it, or you don't have to draw it. You can use the same. Okay, you can use electronegativity. Why? Sometimes there's some strange things happen. This is the thing you can use electronegativity. So, and something happened. For example, let me see. Okay, so now let's see. Maybe if fluorine plus oxygen. Let me think. Okay, if X fluorine plus Y oxygen, and becomes 2 XF Y O. No. YOFXF. Maybe, I don't know. But I don't know how much is X and Y. You want to think F plus O, so oxygen, so F is oxidized. But actually, when you see on the table, you can know that fluorine has greater electronegativity than oxygen, so it's actually taking electrons, so the fluorine is reduced. And oxygen is oxidized, so fluorine is not oxidized, even it's bound to oxygen, so you can what is electronegative? So I just told you, see, F bigger than O, bigger than N, equal to Cl. Okay. Delete O2. Oh no. Okay. Next. So now let's see. So this is usually positive 1 when you see on the periodic table, but not always. Usually positive 1. So let's see. So if this is for metals, it's that the hydrogen, because hydrogen can also be negative 1, 2. And for the 2A, it's always positive 2. And for yes, and but this is usually, but not always. Or some things usually. Yes, some So now it's generally, so the element is always 0. This is always. And now let's see, and if it's ions, which means like this, and this, oxidation number is equal to its charge. Alkaline metal is always positive 2, and alkaline earth metal is always positive 2. No, alkaline metal is always positive 1. Alkaline earth metal is always positive 2. Fluorine gas has an oxygen number of -1 because the biggest, and hydrogen oxygen number is positive 1, but except when it's bound to metal, and then become -1. Wow. So you have the time. So now let's see which one. So if first you can write this. So why? So actually BA is in a 2A group. Alkaline earth is always positive 2, and in this case O is -1. And see, and PO4. So P is has 5 valence electron, and O is usually 2, -2. And now let's see, so PO4 is -3 charge. So and if this is -2 usually, and this is +5. So 4 times 2 is 8 minus 5 is 3. So this 3, so H is +1, so like this, and this is +1 and -2, and you can just write all of that. And then you can find that B and E has changed, and others don't. Okay, so it's very simple. So something that you don't have to see. So there's no element in here, and then there's element in the other side. Then this is the choice. And if there is no element, because it can't be 0 right here. But which element is 0, so there must be an oxidation change. So oxidizing the difference. So now let's see. So it's very simple. So if it is ion, if it is a big, a greater electronegativity, or this, maybe it is greater, like this is the greatest, and you plus a smaller one ions like this, smaller ions, and then there will be reactions. So they will take. Okay. Oh, what happened? All you need to do is to go. So now I think if something that is inside this, and there's hydrogen, and this, and you plus this, and which one is it? So if this can create hydrogen, which means it is bigger than hydrogen. So it's bigger than hydrogen. But when you put this, and you can see the metal, so it is smaller than Zn. So let's see. BASR CA NA and little bit forget here. I see here. Okay, so now you can just see here. This is between H is here, and between Zn is here. FeCONISN. FeCONISN. Wait, back. FeCONISN F-E-C-O-N-I-S-N, 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 F-E-C-O-N-I-S-N. So C and E. Next. Which one does not have a very... So if you have aluminum plus Fe, so aluminum is bigger than Fe, so there is. If the Ne plus En, so Ne is smaller than 0, so no Ni. And if you have this plus this, so you can see Fe and Cl, so Cl is bigger than Fe, so no. Yes. Let me see Cl and Fe. Where's Fe? It's right here. And aluminum is right here. So no. So no. So and B is there's no, and C there's no, and D of course there is, and G plus this, and E, let me see, this is here and this is here, so it's no. So B, C, and E, and all you have to do is say O to those, nothing. And this is last page. Thank you. Ouch, very